Hello everyone, good afternoon. We meet again for a video lecture on machine tool and machining. This is a third year course at IIT Kharagpur. This is being administered in 4 different sections. Students of all the 4 sections are hereby advised to go through the video lecture. In the previous video, we have shown that generalized approach of VC, S and T can be implemented for estimation of material removal rate in milling. Today we are going to check a numerical problem. So we are going to numerically estimate MRR using the normal approach of B into S, M into T, as well as using the generalized approach of VCS and T. So let us look at the problem statement. This is the width of the job. This is the diameter of the cutter. Last time when we have discussed, we assumed that the width of the job is equal to the diameter of the cutter. This is much more actual industrial application where the width of the job is less than the diameter of the cutter, for which you have a entry engagement angle and an exit engagement angle, which are not minus pi by 2 and plus pi by 2. They are something less than 90 degree on both the sides, and this is the instantaneous position of the insert. This is the instantaneous engagement angle. Now let us look at the numerical data. The width of the job is 113 millimeter, which is 80 root 2 millimeter. We have taken this for getting some typical values of engagement and exit angle. The diameter of the cutter is 160 millimeter. It is symmetrical face milling. That means the center line of the job and the center line of the cutter, they coincide, and numerical value of the entry and exit engagement angles would be same. Just like in the previous occasion, we are solving it for only one cutting edge for fly milling. So one cutting edge. Feet per tooth, which is also feet per revolution in this particular case, as Z equal to 1, is 0.2 millimeter per revolution. Axial depth of cut is 5 millimeter and the cutting velocity is pi meter per second. So roughly 3.14 meter per second. So this is the numerical data. Now if you have to estimate the material removal rate using the standard approach, it is very simple. So let us do that first. So meter per second becomes millimeters, so 1000. It is meter per second, it gets multiplied by 60 to bring it to millimeter per minute, which is equal to pi dn. There is no divided by 1000 because this is in millimeter per minute, which gives us a value of rotational speed of 375 rpm. Once the rotational speed has been obtained, we will calculate feet per tooth. The feed rate. Feed rate is feet per tooth into number of tooth into n, which is 0.2 coming from this particular place, Z, which is 1 coming from here. So it is a case of fly milling. It is a case of fly milling, and 375 rpm. So that gives us a feed rate or speed with which the cutter moves as 75 millimeter per minute. So MRR would be axial depth of cut, width of the job into SM, and if we do that, we get an MRR of 500 root 2 millimeter cube per second. Here again we are dividing everything by 60 to convert from millimeter cube per minute to millimeter cube per second. So that comes out to be 500 root 2. This is very simple way of estimating material removal rate. This we have already done in the class. But we are not going to follow this method. We are going to follow, or we are going to check whether VCS and T, VC into S into T serves the purpose or not. Why we are doing it? This simple one, for benchmarking operation. We will compare the VCST, that is the generalized approach, with this. So this is the same view. This is symmetrical milling. So this is B by 2, this is D by 2. From this geometry we can find out entry and exit engagement angle. They would be numerically same. So to find them out, this particular is sine inverse B by 2 by D by 2, and that becomes pi by 2. So this is basically minus 45 degree, this is 45 degree. Once we have found out where from the cutting is starting and where it is ending, we would be able to find out the average feed. In the previous video we have introduced the concept of average feed. An average feed would be instantaneous feed integrated over the engagement angle divided by the total engagement angle. From this place to this place it is pi by 2. It could have been written as integral d psi I minus pi by 4 to pi by 4. It would have been the same thing. So this is SI is nothing but S cos psi I. This was discussed in the previous video, the last video that we have shared with you, and from that S average will come out to be 2 root 2 by root 3, 2 root 2 by pi. That means this is pi by 2 and the integration of this would become root 2. So this is a screenshot from integral solution. This is a website where numerical integrations can be done very easily. So this is the variation of cos x or cos psi, and this being integrated from minus 45 degree to plus 45 degree. These are the area, and that area is nothing but root 2, from which we get this particular value. Now what are we going to get here? Now let us see whether we can discard this or not. Okay, so it becomes VC S average into T. Now VCS average into T is VC is nothing but 1000 pi, because it was pi meter per second, so 1000 pi millimeter per second. S average is 0.2 into 2 root 2 by pi, that we have simply derived here, and this is 5. This 0.2 is nothing but the value of S which was given in the previous page. Now something strange is appearing in the denominator. Please try to understand, cutting is starting from this place and it is ending here. So it is cutting for not the complete revolution, it is cutting only for pi by 2 part of the revolution. Rest of the part, the insert is not removing any material. So the total revolution is pi by 2, of which 2 pi, of which pi by 2 amount it is removing. So that ratio is 4. So this is 1/4 of the time it is removing that material. If you put all the numerical values there, you will get a value of MRR which is 500 root 2. So it is the same value of MRR that we have obtained earlier using our normal approach, pi by root 2, the standard approach. And the same value of pi by root 2 can also be obtained once we are using the generalized approach of VCS into T. Thank you so much for your time. I would request our student to subscribe and press the bell icon, so whenever we are uploading the video you get a notification. All other viewers, if you are liking our channel and the videos, we will request you to subscribe as well as press the bell icon. During this time, stay safe. Thank you so much for your time.